Inductive reactance. This ring consists of a wire coil. The only pure resistance is the copper wire itself, which is only 8.5 ohms. Ohm's law. Current equals volts divided by resistance. Using Ohm's law, if there is only 8.5 ohms of resistance plugged into a 120 volt wall socket, there will be a 14.1 amp draw, enough to trip a 10 amp circuit breaker. Let's plug the coil into the socket to determine if the circuit breaker trips as predicted. The lights in the room are still on. Why didn't the circuit breaker trip? The circuit breaker does not trip because the coil is an inductor. In addition to the pure resistance of the wire, there is also a resistance to alternating current, called inductive reactance. Here is the formula for inductive reactance. X sub L equals 2 times pi times F times L, where X sub L is inductive reactance and is measured in ohms. 2 times pi is a constant in the formula that equals 6.28. F is the applied frequency, which is 60 Hz from an AC outlet. L is the inductive value of the coil and is measured in henries. Okay. Using an inductor capacitor tester, the value of the inductor in henries can be determined. By plugging the inductance value of the coil measurement into the formula, the coil's inductive reactance can be calculated. The inductive reactance, X sub L, of 23.4 ohms and the pure resistance, R, of 8.5 ohms contribute to the total opposition to current flow, called impedance, C. Using Ohm's law, if there is 24.9 ohms of impedance plugged into a 120 volt wall socket, there will only be a 4.82 amp draw, far below the amount required to trip a 10 amp circuit breaker.